Rodriga, both excellent meteorologists. That's really, really good. You might see these kind of weather maps with lines of equal pressure. Basically, you can track kind of low pressure systems and high pressure systems as they're moving across. The tighter those lines, the tighter what we call the pressure gradient, and subsequently the stronger the pressure difference over that area, the stronger the winds. And if the lines are further apart, it's a weaker pressure gradient, so weaker wind. That's basically how it goes. One of those things, if you can't actually see the difference in the lines, you know it's really, really windy. And that does happen sometimes on the West Coast. So it's just a stronger wind with a stronger tightening of those lines of equal pressure there. Now, that's kind of the basics of wind, but now how do we measure it? And what are we measuring it? And where do we measure it? And these are important just to kind of think about, because sometimes you may say it's blowing, 25 knots, and yet the observation station might say, 15 or 17 or something like that. What's going on? So it's important to know that the winds that we measure and that subsequently we forecast for, and we can kind of do verification statistics on, which is, a standardization right across the world with the World Meteorological Organization, are these kind of heights. So for land-based stations, we're measuring the winds at 10 meters, 30 feet or so. And for buoys, we're measuring them at 5 meters. This is going to have a little bit of a consequence in terms of the frequency that we might be sampling the atmosphere, especially with buoys, to kind of put a picture on it. Sometimes the buoy could be, as we talk later with waves, sometimes the buoy could be in the trough of a wave, and it just happens to be sampling the wind at that moment as it's in the trough. Subsequently, it could be at the crest as well. And this impacts the types of wind measurements that can be done. So for buoys, we have to kind of think about the sampling maybe differently than we would land-based stations. Something else to think about is that on average, it's usual that wind speeds will increase with height as you go along. So the closer we get to the surface, there's usually what we call surface friction involved in terms of buildings, trees, any sorts of terrain that are usually able to slow the wind speeds down as we get closer to the surface. But the further you get away, it's quite free to flow with no obstruction. So typically we would see the wind increase with height as we go up further up. So with the image there, it does matter where you're measuring the wind. So the little buoy that's down there is measuring at 5 meters and perhaps is only measuring with this illustration here about 30 knots. But you go way up high to a big ship, and perhaps their anemometer, the instrument that we take to measure wind speed, is at 35 meters, and they're saying it's blowing 50 knots. What are you guys doing? You guys are way off. And what we have to kind of say is, well, typically the first question I would ask is, where is your wind measurement? And usually that's kind of that kind of solves the puzzle there. So where you measure wind is important. So if you're kayakers, I don't think this is a significant issue. When I've talked with other folks, say power boaters or even sailboats and that sort of thing, this can usually come up in terms of, oh man, I'm feeling such and such. But I think for you guys, I think this shouldn't be as big a dilemma, but it's just something good to know about. So which wind is being forecast when you look at, say, a forecast for the Strait of Georgia or Juan de Fuca or Haro Strait? Where, what wind is actually being forecast. So here's a forecast for the south of Nanaimo. And we've got some wind speeds mentioned of light increasing to southeast 15 and then further to southeast 15 to 25, and then becoming westerly Thursday morning 15 to 25. So those are all the speeds. What's actually being talked about here? These 15 knots, 15 to 25 knots. Well, we're going to call them something called the sustained wind. That's what we're forecasting. And so when we go now to some of our observations, how do we actually compare? What are we measuring to get this kind of, hopefully what is our forecast? So we go to, say, Herbert Island, northern kind of areas of Vancouver Island, and you've got a wind here that is east-southeast 18 gusting 25. So what are those winds being observed relative to what I just talked about in terms of our forecast wind on the previous slide there? And so what are these winds observed? Well, 18 is the sustained wind. So that's what we're forecasting for. And then 25 is the gust. Pretty self-explanatory there with the recording as well. And so you've got 18 sustained, you've got 25 being the gust. So how do we get that number from these stations? This land-based station, and it could be Herbert, but it could also be Sisters, it could be Race Rocks, it could be Sheringham. How do we get these numbers? So we're going to talk about sustained wind, and the sustained wind that we measure with land-based stations is the 2-minute average. What do I mean by 2-minute average? Okay, we're going to delve into a little bit of technical graphs, but hopefully I don't lose anybody here. It's pretty straightforward. In the gray line, you've got the atmosphere being sampled by this land-based station basically every second. So you have time across the horizontal in seconds, and you've got the wind speed observed in knots. And so you can see in the gray line there, it's the atmosphere is being sampled every single second, and it's quite jumpy, and it's going boop, 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 boop. And so that's the sampling, that's the 1 second sampling on the land-based station. Well, the 2-minute average smooths that out. It basically takes the average of those 2 minutes. So it basically takes all those observations and then kind of smooths it out and averages for the 2 minutes. And then that's what we see as the sustained wind. So in this case, we've got the 2-minute average being about 13 knots or so, depending on where you are in that curve, kind of 10 to 15 knots, but more on average of about 13. But you might say, though, that given the sampling there, that's the sampling is actually showing a much stronger instantaneous wind of 27 knots. This is where the sustained wind can sometimes miss those peak winds. And that's where gust wind comes in. So 2-minute average for the sustained wind. How do we capture, or at least try to capture, that 1 second max peak? Well, the gust is the highest 5-second averaged wind. So we can capture that a little bit. We get most of it, I would say, based on this kind of sampling. So again, same graph in the gray, time across the horizontal, speed in the vertical, and the 1 second sampling is in the gray. Then you've got the 5-second average, which is now in blue, kind of correspondingly overlaid. And it's not quite capturing, say, the peak of 27 there, but it's certainly close, and it's much more representative. So when we do forecasts of sustained wind, just to bear in mind that that's the 2-minute average. And if we put gusts in our forecast, which we sometimes do, depending on the weather situation, I would say it's not common, but sometimes we do put them in, that we're looking at it at the 5-second average. So if you're seeing stations measure wind, just kind of bear these in mind. The instantaneous wind that you might feel it might just get a little bit above what's actually being observed, and that's just the averaging and the smoothing. So what about buoys, though? A little bit, just something to think about. We kind of talked a little bit about earlier, the issues of the buoys maybe being in the trough of a wave, that it might not be sampling the wind. The sampling is going to be difficult. It's going to be kind of depending on where you are on the wave. So it's basically the thing that we kind of do to try to nullify that and try to smooth it out and get a better representation of what the atmosphere is doing in terms of wind speed, is we are going to just make it a little bit longer. Instead of a 2-minute average, we're going to look at a 10-minute average wind speed. So it's just, it's something else to kind of just add to, just when you're thinking about when you're seeing observed winds, that the buoys are taking a 10-minute average as opposed to a 2-minute average for land-based stations. So a little bit, just a subtle differences there. So we kind of gone through what wind is and how and what causes it. And now we've kind of talked about, what are we actually forecasting, what's observed in terms of sustained wind, gusts, and that they capture most of the story, but sometimes the peak winds can be just slightly higher. Now the effects of terrain. And this is the fun part of living here where we do, in arguably the most beautiful part of the world. We live where we live for a reason. And certainly we're very, very blessed to have such beautiful scenery and beautiful terrain, mountains and water, and everything converging together. But amongst this beauty, it does cause rather significant havoc in terms of local effects with wind regimes. And there's a lot of variability that goes around, and depending on where you are, the influences of the weather pattern, inflow, outflow through inlets, whether a particular bay is sheltered. If it's on the lee side of a mountain, perhaps it's sheltered a little bit, but maybe you're on the windward side and you're going to get blasted. It all kind of just depends on the topography and the variability of everything. So lots of things to consider. As an aside, I'll just say that sometimes actually what we as a marine forecaster, sometimes I actually enjoy a good, strong, low pressure system. Yeah, it rains and it's windy and it's maybe not a lot of fun to be outside. It can be a challenge, but the local effects tend to be nullified in that case. And in many ways, as long as you've kind of pegged the trajectory of the low pressure system pretty well, generally the wind regimes, you can kind of predict them, and they respond accordingly with the particular, if it's a southeasterly through the Strait of Georgia, or if it's easterly as the low is approaching, and then the low goes by and everything in Wanda Fuca goes west. That's in terms of a predictability is sometimes easier to call than a big ridge of high pressure, where and typically if it's a big ridge of high pressure and there's no overriding wind regime present, strong wind regime present overall, then the local effects take over. And when the local effects take over, they become a little bit more of a challenge to predict. Some of the diurnal cycles in terms of inflow, outflow, flushing in, flushing out, daytime heating, we have a pretty good handle on that. But sometimes it's the subtleties of Mother Nature and the subtleties of the topography come together, and it can be a bit of a challenge. So just looking at all the different potential, things to think about. Lots of inlets in the marine forecast world in terms of what marine regions we forecast for. We have Wanda Fuca. We split it up kind of east to west in different chunks. We have Harrow Strait. We've got the Strait of Georgia. We do Howe Sound. We don't do any of the, say, Jervis Inlet or further north into say north of Texada. So it's our marine forecasts cover a lot, but in terms of some of the finer bays or some of the finer inlets, it's left to more local effects. So in those situations, honestly, we actually sometimes rely on your expertise on and experience if particular bays are sheltered or not. But we also have different high resolution computer models now. And this gets into a little bit more, and again, it's more of a little bit of a tease for later in the talk, but I'll be sharing some of the information that you'll be able to contact us one-on-one. And if there's particular inlets or bays that you're looking at getting into, we can try and help you out there. And so we have high resolution computer models, and this particular one is showing one of the Qualicum wind effect, and also a fairly significant gale through the eastern sections of Juan de Fuca. These models are getting better and better. A lot of them are appearing on the web. This particular one that I'm showing you here is one that's in-house and is a 2.5 kilometer resolution model. So it can get pretty good resolution and scale down. And at the end of the talk as well, I've got a link, as well as it's password protected, but basically I can give that to you guys and you guys can access that as well. So something else in your toolbox as you're kind of making decisions on whether to go out or not. So other toys that and tools that we've got is new satellites. And so we've got the high resolution kind of image on the left. On the right-hand side is a satellite image, kind of roughly of the same time. And some of our new satellites, it's pretty amazing what they can do, but they can basically look down and determine the wind speed basically of a particular, it's not always continuous with the satellites in motion, but we can get ideas of how strong the wind is via satellites, which is something quite new. We have some of the new geostationary satellites that have gone up in the last few years have replaced some old ones, some legacy ones. And I'll step just briefly aside and I'll just say the amount of data coming in is phenomenal. And we are a data-driven industry. I think one of the biggest challenges going forward for meteorologists is managing big data. And I suspect this is the case for many professions, but in particular meteorology being so data driven, and these new satellites that are up in the sky, just for perspective, the first 6 months that they were in operation, they took as much sampling and data was generated from them as was done in the previous 30 years from the previous generation of satellites. So how we manage all that data, how our own supercomputers assimilate it and build better computer models for better forecasting, as well as the machine-man mix, as well as the forecaster ourselves having to kind of process that and kind of build the weather story. It's a big challenge, but there's some really cool things that are happening, and this is certainly one of them. This is another one from basically it's an area of high pressure. And one of the subtle effects that can happen is a lee low that develops off the west coast just south of Tofino. And what ends up happening is if we get it's typically in the summertime, but we would see outflow conditions pushing kind of an east to northeast wind in some direction. And when you push the winds down across the mountains of Vancouver Island, you can actually get a low pressure areas developing. It's subtle. It's, perhaps it's not as significant as maybe a storm or a gale force wind, but you can see here, if you pick off, say, Tofino, and you're looking at the one observation from the buoy in the area is showing kind of a southeasterly at about 15 knots. The long just a little weather 101 in terms of how to read the wind barbs. Basically, it's just one full long is 10 knots, and then a little one is 5 knots. So 10 plus 5 is 15. So 15 knots there and out of the southeast. Well, it's the only sampling of surface data that we have, but clearly there is some sort of circulation. So I suspect if you were a little bit further west, you would probably actually see a west to northwest observation. We don't have that, but fortunately we do have these new wonderful toys in the sky that can see these sorts of things and certainly help us better with the weather. So, so I'm gonna just as we've kind of talked about wind, we've talked about in terms of how we measure it and sustained and gust and that sort of thing. We've talked a little bit about terrain. I'm just going to delve just a little bit into pressure slopes, and I apologize if I lose people. we won't stay in it too long, just about 5 minutes or so, but I think it's really important. A lot of the work here that I'm going to show comes from a couple of books written by an ex-forecaster who's unfortunately no longer with us, but Owen Lang was a longtime Environment Canada forecaster and marine forecaster, and he wrote a couple of books, and a couple of the resources which I'll share with you at the end. They are kind of the holy grail, that the Bibles really of what new marine forecasters need to read when they get spun up on the desk, and they're available when we've done boat shows and we've gone out to different groups. We've been able to usually give these books out. Now, of course, everything is digital, and they're actually available online, which is kind of nice. So I can share those with you and those resources at the end of the talk as well. So these pressure slopes are from Owen's books there. And basically it's just the idea that, wind is driven from high to low pressure, as we've already talked about. But in the south coast of BC, there's particular pressure slope regimes that kind of dominate, or more dominant than most. And depending on that pressure slope regime can really dictate how the winds will behave in particular areas of the south coast. So I'll touch on a couple, just looking at the south coast, and we'll focus in kind of on the Georgia Basin. We'll focus in primarily on the Strait of Georgia, and we'll also do Juan de Fuca. And so, but if in Owen's book and in the digital copy online, there's particular areas shown. So if you want to go into a little bit more detail of, say, Victoria, the Islands, Vancouver area, Desolation Sound, as well as up the Central Coast into the North Coast, there's particular wind regimes shown there as well. So a really, really good resource. So I'm just gonna give you a little teaser. So, but it's really, it's pretty cool stuff. So common pressure slope patterns that we see in the South Coast: southeasterly, generally meaning an approaching low pressure system or weather front is on the way. So something off in the Pacific is here it comes. And so all the winds are starting to kind of flow in that direction towards the incoming low pressure system. We see when the front or the low goes by, the pressure slope flips, and the low is now somewhere in the interior or Washington state. So now the winds are actually blowing west or northwesterly, what you would probably see as a very good, and what we'll see with the as we go through the examples, just a very strong westerly, say through Juan de Fuca in particular. That's when Race Rocks gets some of their nice strong winds. Other kind of interesting ones to think about: outflow winds, generally usually more dominant in the wintertime. Summertime can have an impact as well. Sometimes, actually, just as an aside, that's our heat dome that we had last year. If you really want to get the temperatures even, that are hot, but even hotter, draw those interior winds out with outflow, and then have them subside adiabatic compression, and the wind and the temperature will actually gets that extra little boost as well. So we can see some of our hottest temperatures with outflow from hot interior air. And then just a kind of a general kind of slack Pacific high with a westerly flow. So this is kind of the pressure, what you'd see if you were watching, say, your news and maybe a weather map with Mark Madriga or Christy Gordon. Here comes the southeasterly approaching front. So again, lines of equal pressure. So you've got high, which is presumably over in, say, Washington state or the interior here, and you've got kind of a southeasterly flow with across the pressure lines, kind of perpendicular to there. And then in the westerly regime, you've got a high that's kind of building off. So again, some low in the interior, and you've got kind of a flow pattern that should be, kind of west or east, or west to east, I should say. And then outflow, typically a strong high, usually an Arctic high, especially in the winter, and then strong outflow winds, usually through the inlets, and that's a common one as well. So if we look at, say, the pressure slope for a southeasterly for, say, Georgia Strait, typically what we would see, again, an approaching front, typically we see the strongest winds in the northern part of the strait. So Sentry Shoal, the northern half of Texada, as opposed to further south, closer to Nanaimo and that sort of thing, Vancouver. If we look at the same regime for Juan de Fuca and around Victoria here, we've typically got a little bit of a strong push out of Puget Sound. That's kind of got a stronger burst of winds through Harrow, but through Juan de Fuca, it's not too bad until you get to kind of the western side of it. That's a bit stronger. But now the low goes by and we get northwesterly. So in Strait of Georgia, that flips, whereas the strongest winds were up near Sentry Shoal and northern half of Texada. Now we flip them and it's actually closer to Vancouver. And for Vancouver, at least, they can get some pretty strong winds, and some of the stronger windstorms can actually be northwesterlies. And similarly, Race Rock, Sheringham, it's full on when the front goes through, and so very, very strong winds through especially the eastern sides of Juan de Fuca there. Something just briefly to talk about, and I kind of touch on, is sometimes they talk about return flow, and this is kind of a term that we use in the weather office, but sometimes it can it's just interesting thing to kind of follow. And what happens is you've got maybe northwesterlies down the Strait of Georgia, light to moderate of some nature, but you've got this burst of, say, westerlies through Juan de Fuca, and air is a fluid, and the air has to go somewhere. So where's it going to go? So it's going to travel east. It's going to basically wrap itself up and around up into Harrow. So that stream is going to go that way. Another stream is actually going to go down into Puget Sound and kind of split a little bit. So that that flow that kind of goes up through Harrow, it does eventually get into the southern half of Georgia, Strait of Georgia, and can actually impact the wind regime as far north as say Texada Island. So something it's a subtle feature, not really important. There's no test at the end, so it's not like that. So we're going to test you at the end on this, but it's something, the subtleties of the weather around the West Coast, and it's certainly something that we need to kind of keep an eye on when we're doing the forecasting. So strong winds through Juan de Fuca can sometimes mean, just to keep an eye on, maybe you're expecting northwesterly all the way down, but these southeasterlies can kind of push back. The southwesterly pressure slope, we talked a little bit about the Qualicum effect. So, so that's shown kind of there. Again, kind of the westerly pressure slope pattern from, again, through Juan de Fuca. Outflow. This is, it's always a bit of a challenge with this. Through the main kind of the inlets, it's always going to be stronger. When I focus, say, for you guys down in Victoria, it's this is actually the regime where it can get pretty nasty, and in particular, if it's wintertime, as this pattern, or as this illustration kind of shows, it's actually your favorable snow pattern, because those winds that are spilling out of the Fraser Valley usually end up kind of close to the greater Victoria area, somewhere in there, depending on the exact direction. And it picks up the moisture across the Strait of Georgia, and it has nowhere to go. And the first sign of any land, it goes up and it just can be dumping a lot of snow for you guys there. So that's just a little aside for wintertime weather. This is a preferred pattern, but particularly nasty outflow as well, all the way down with strong winds. So just to kind of take a step back, and in summary, it's the wind is kind of measured at different heights, just to kind of keep that in mind. depending, where the station is, if, maybe a particular station might be blocked depending on the terrain and may be exposed to another direction. So one station that's usually pretty good for this is up in Johnston Strait, and that's Fanny Island, and it is exposed particularly to northwesterlies, but for southeasterlies, it's a little bit sheltered. So usually it's just another kind of complicated thing in terms of looking at, say, surface observations with wind forecasts. The terrain does impact things, and knowing which stations might be sheltered and which stations are not from different wind flow directions. So yeah, the bottom line is we try our best to put it all together and build our meteorological puzzle in our heads to make the best forecast. So with respect to, we've talked a lot about wind and various components of it. I wanted just to touch on waves as well. It is part of our marine forecast, and it is somewhat good to know a little bit about waves. So just some very, very basic aspects of waves. Wave height is something that we forecast for. We call it the significant wave height, which I'll talk about in just a little bit. But the very basic is, what is a wave height? Well, we're basically going to look at the wave itself. It's going along. We're just going to measure from the crest to the top of the wave down to the trough. And that is what we define as the wave height. So significant wave heights is generally what we forecast for, and what we typically what we try to actually report with some of the observations. We also measure the wave period, which is important in knowing how often you might be seeing these significant waves, or even perhaps maximum waves. And so we'll just touch briefly on this. Significant wave height, we'll just define it there. It's the average height of the highest third of the waves. So as I'll show in a little image next, think of, say, your buoys there, and the waves are just hitting it, boom, 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 and it's sampling. Every single time a wave hits it, it's sampling. And so we're taking all of those waves, and now we're going to take a third of those waves, and the basically just use that as the height of the highest third of the, or at least the highest third of the waves are going to use that as the wave height, or the significant wave height. And then there's something we call the peak wave height, and anecdotally, it's basically, on average, it's about just twice the significant wave height. So this image just kind of, we've got wave height kind of across the horizontal, and we've kind of got the number of waves reported basically across the vertical. So the highest third of the waves is kind of indicated with this kind of black line over to the maximum kind of wave detected. And then beyond that, behind that, you've got the kind of 2/3, the lower 2/3 of the waves that are reported. So we're basically going to take those highest third of the waves, and we're just going to take the average. And it turns out that that is what we forecast for, as called the significant wave height. That's the WMO standard that has been decided on. So in terms of the wave forecast, that's what we try to forecast for. So although you may see many waves that may go by, 2 out of 3 are not actually that high, the wave height for, say, 1/3 of those usually should be. So, and then the peak wave may not be quite the maximum height, but it's close. So we're going to do double the significant wave height there. So when we look at, say, a wave forecast, and goodness knows, I hope you're not out here with 7 to 10 meter waves or something like that. What are we talking about? We're talking about basically the significant wave height. And so we've got a little, just basically saying here that if you've got a significant wave height of 5 meters, that perhaps 1 in 10 waves might be 5 meters or so. And if that's the case, then maybe 1 in 1,000 maybe double that at 10 meters. So leave those numbers in your head, and we'll talk about wave period, and then we'll kind of put the two together and maybe how often you can expect them. And wave period is really just looking at the wavelength from, say, crest to crest, or it could be trough to trough as well, I suppose. And we're looking at just how long it takes for a wave to travel one of those wavelengths. So we've got a wave period of, say, 6 seconds, and I'm making kind of the math relatively easy here. So 6 seconds if the one wave is coming by every 6 seconds. Well, that means that there's going to be 60 seconds in a minute. That means there's going to be 10 waves that pass that buoy every minute. Or 60 minutes in an hour, it's going to be 600 waves, or roughly 1,200 in 2 hours. So if a peak wave from our previous example occurs every 1,000 waves, and that peak wave is 10 meters, then given the wave period of 6 seconds, you're encountering that on average, maybe every 2 hours or so, slightly less, but on average about every 2 hours. So that's how you can kind of put together, say, the significant wave height, the peak wave of maybe what you might expect, and how often you might encounter that based on the wave period. So kind of continue on and kind of slowly wrap things up with just kind of briefly touching on the wind warnings. And I think hopefully most people know most of these. But it's good, always good for review. Used to be, of course, known as small craft, but now we use a strong wind warning. And for us, it's kind of a seasonal thing, but it's basically anything less than a gale, so anything less than 33 knots and picking up into the 20 knot range. So, and for the US, it's a high wind warning. So moving on into our next category, which would be gale force. And those are winds of 34 to 47 knots. And you can probably guess what's going to happen with the pictures. It gets increasingly a little bit nastier. So storm force winds is the next category. And those winds are of 48 to 63 knots. And then, of course, we have our day after tomorrow, our perfect storm, our hurricane force winds with sustained winds of anything more than 64 or more knots. So, and just to, I guess, as an aside, although we don't see hurricanes, also known as typhoons or cyclones, depending on which part of the world we're in, but we don't see hurricanes here at least on the South Coast. It's just the waters just aren't warm enough to sustain them. And get them up here. Now, certainly if you go down to along the Mexico coastline or even Southern California, you can sometimes see them spiraling up from the tropics. But that is not to say that we don't see hurricane force winds along the West Coast here during what we call kind of storm season, generally kind of October through, December, January. On the west side of Vancouver Island, through kind of Queen Charlotte Sound and up into Hecate Strait, kind of through along Haida Gwaii. It's not uncommon. It'll happen at least a couple, maybe even a few times a year, where we will get at least hurricane force winds somewhere in that kind of a corridor, depending on where the low pressure system is going. The good news for us down here in, say, Victoria or Vancouver is, I think the strongest we have to usually contend with is a storm force warning, and that does happen at least a couple times a year, but certainly no hurricane force winds. That's for the west side and for the north and central coast. So, although we don't get hurricanes per se, we do get hurricane force winds. So so summary there. Interpreting the forecast, kind of the last section. And in this one, I'm kind of just gonna kind of go through a few bits of how to maybe interpret our forecast, some other resources that you might be able to kind of incorporate and use. And in addition to that, it'll be some kind of high resolution computer models, which I can show, as well as contact information for us If you want to talk to me, you want to talk to whoever's on the forecast desk this evening or whenever, if you need a little bit more information, a little more confirmation that the forecast is going to do this or that, or maybe our marine forecast, as you'll see, we do marine forecasts out 5 days. Our public forecasts at Environment and Climate Change Canada go out 7 days now, but our marine forecast still only goes out 5 days. And so maybe you're planning a longer term trip, and you may want to know what the weather is in 7 to 10 days and that sort of thing. Of course, the caveat with that is that, as you move further away in time, into the future, the less certainty that we'll certainly have in terms of the weather and the forecast. But I would certainly say it's worth giving us a call if you are planning a longer term trip, because although the marine forecast may stop at 5 days, we might be able to tell you that, this particular pattern of high pressure and, relatively benign weather might continue. And it looks to continue well into next week. Or maybe we're going to see a pattern shift and, something more active or that sort of thing. So although we may not be able to fine tune specifics, we can certainly help with trends and that sort of thing, and help to kind of give you confidence or help with any kind of potential planning and that sort of thing. So just a little heads up there, and we can talk a little bit more about that as we get to it. So, but here's an image of and I'm just going to maybe point out the blue that's in the northern part of Georgia. So we've got Vancouver and Victoria kind of highlighted there, but up north of Texada, we've kind of got this blue. And the blue, if you go to the right-hand side of the chart there, it's kind of color-coded with respect to the different speeds and knots, and you've got 30, maybe as high as 35. If you go down, to the southern half of Texada, you've got this red area, and it's more 25 to 30. And of course, as you get along the coast, whether it's the mainland or the island coast, it's a little bit less. And so what is the forecast going to be? What does this actually look like here? And so the forecast that particular day was mentioning basically there's a gale warning in effect for the Strait of Georgia north of Nanaimo of 25 to 35. Well, that particular image can kind of fine tune things of where the strongest winds are going to be. Although our area is certainly, the region itself is quite large. So is the whole thing going to be 25 to 35? Generally, I would say in our marine weather forecasts, we look and we err on the side of caution. Our responsibility is your safety out there. And so we're going to usually err on the side of caution and forecast what we think are probably going to be the strongest winds. But in this case, 25 to 35, although it captures things very well, the fine minutia of things shows that it's actually the strongest potential gale force winds may actually be up north of Texada. And so that fine detail with the high resolution models can kind of help you out there. So interpreting in terms of the forecast, just from our website here, you go to weather.gc.ca. You've got all the different options. You've got the marine option here, so we'll click there. And you can look, of course, at any forecasts right across the country, but we'll focus certainly on the south coast of BC. And you're taken here to the south coast forecasts. All of our warnings are done in red. I wish they were be color coded, because it looks like the whole, especially in the fall, everything is always on red alert. In reality, it may just be a lot gale warnings or something like that. It would be nice to be able to color code them, because a gale warning will show up as much as a strong wind or even a hurricane. But all of our warnings are shown in red. And so you can focus again on Strait of Georgia north of Nanaimo, and that's where you get the forecast there. And then if you'd like to perhaps look and say, okay, we've got the forecast, but what are the conditions right now? So across the top here, these different tabs. And although we're not going to be checking any ice conditions in the Strait of Georgia north of Nanaimo, hopefully, we can certainly check what the weather conditions are. And so if you click that tab, you're brought to this page here. And what you're being shown is you've got the buoys that are identified in red dots. And so you can click on them to see what the observations are in terms of wind speed or wave height and that sort of thing, wave period. And then the land-based stations are in kind of the green diamonds there. So let's pick one, say Sisters, and we can click on it and just see what's going on. And you click that and you're basically given the current observations, and it's got the wind speed, it's got a few other things as well in terms of temperature and pressure as well. So you've got the current observations there, which you can kind of drill down into. Now, sometimes knowing trends is good too. You may want to look and say, oh, maybe the forecast was showing strong winds. Maybe and they're supposed to be coming down a little bit. Has it started doing that? So you can go back and you can kind of look at trends as well and see where things are at. And we certainly would, it certainly can be a helpful thing to do. And so that wind speed is for the last 24 hours is shown there, as well as, of course, other kind of weather parameters there. If you do want to look at some of the lighthouse reports, they are on this page as well, and they're just kind of down highlighted there. And so you can get those lighthouse reports there as well. One question that I get is, in terms of what do you mean when you say early morning, late morning, overnight, and that sort of thing? Again, winds maybe 10 to 20 knots increasing to the 25 to 35 early this afternoon or early this evening. This is kind of our in terms of how the phraseology kind of lines up with the timing. And so morning is 6 a.m. to noon, afternoon, noon to 6 p.m., evening 6 p.m. to midnight, and then midnight to 6 a.m. is what we consider overnight. And then early and late correspondingly to those kind of 3-hour blocks. Now for the reach out and certainly if you want to contact us. And I can share actually, I was going to share a summary sheet with some of this information on it as well, kind of summarizing a lot of these at the end as well. And I can share that maybe so you guys can all get that afterwards too. But these are basically the phone numbers if you want to contact us and speak with a forecaster on the desk. These are the phone numbers. So there is no charge. It's taxpayers' dollars which have paid for it, so it's free to call and talk to one of us at any time. And so generally most hours of the day, during the day, we're kind of close the lines down overnight, but most hours during the day you can contact us there. And if you want to talk to a public marine forecast or a public forecaster as well, that number is there as well. Actually, turns out the desks are not all that far apart. And if you just happen to get the wrong number and you dial the wrong one, don't worry, we'll just transfer you, just yell it over to the other person, and they can help you out. So it's going to the same office, but just different desks. But those are good resources. So if there's any questions, and it can be a forecast, maybe if you want a little bit of fine tuning on the day, or again, trends in a 7 to 10 day outlook, or if you have a question, please feel free to contact us. We're absolutely willing to, and more than happy and willing to help there. So we've also got our marine recorded line as well, which is kind of at the very bottom there. So just in kind of closing, kind of rules of thumb, how to forecast your own weather. It's just a little bit of a fun thing to put at the end, but there is some science behind it as well. The red sky in the morning, yeah, sort of. But certainly if the pressure is falling, if you are seeing some sort of a humidity increase, temperature is changing, it's usually an indication that there's low pressure on the way in some fashion. Maybe it's not going to be a weather bomb or anything significant, but some kind of a storm may be on its way if pressure is starting to fall. And what we would typically see is, with any kind of a low pressure system that we see on the coast here, we usually see clouds high out over the system will usually start to approach first. So we'll usually see some high cirrus clouds, and then gradually as the actual storm approaches, those clouds will deepen and they'll thicken, and we'll usually start to get a little bit darker. And typically what we see ahead of it, again, with the low pressure system kind of approaching from the Pacific, is usually a shift kind of east or southeast winds. So that could be an indication that something is on the way, and your time may be limited there. But on the other hand, maybe the low has now pushed into the prairies, perhaps it's into Washington State or Idaho, and we've got a west or northwest, right at the transition of that front, can usually be a little bit nasty. So again, Juan de Fuca, race rocks usually blow a good stiff west, and then through the Strait of Georgia can be a stiff northwest, right at the point of that change in the wind direction along the weather front. But as the whole system moves along, gradually we usually see the west or northwest, they start to abate and they start to lighten up a little bit on average. And typically we would usually see the clouds clearing out a little bit there and the pressure rising. So I had mentioned, I guess, a couple of the resources. So these are the two books by Owen Lang. So if you can get your hands on them, they're excellent. But I don't know, honestly, actually, if they're in print anymore. And so I know our copies, we would give them out at the boat show, actually, and have them at our booth. Hopefully in pre-COVID days, and hopefully we can return hopefully next year in 2023. And so we usually be giving them out, but we've started to run quite low on copies. So all the information was basically digitized and put together from both books into this publication, which is available. And this is the link for it here. And again, maybe after the talk here, I do have a summary kind of Word document, which I've kind of put together, and I can send to Lynn or Fred and make sure you guys all have a copy of it as well, just kind of summarizing the different resources available, which I'm kind of showing here at the end. So no need to quickly jot down this big web address. There is the Marine Weather Guide as well, and it's available at the website just below there. And again, that'll be on the summary sheet, which I can forward for you guys. But this is a really nice kind of one-page. It shows our marine regions. It also kind of highlights, the different buoys or the land-based stations, as well as some weather radio and some other information as well. There's even more. This is what I talked about was more of the regional, or BC or South Coast specific resources and BC resources. There is a national online marine guide, and this is the website here as well, and I'll have that on the summary sheet as well. But if you wanted even more detail, you could certainly look at that as well. So there's no shortage of information to kind of empower you guys. This is for the weather nerds. I wanted to include this, and you're like, what's the deal? This is, we're talking about, water, and we're ocean kayaking and that sort of thing. Like, what's going on? Why are you dropping an avalanche forecast on us? But this is a really good resource if you are kind of interested in a little bit more of the ins and outs of weather. It's a daily blog that we do for our partners at Avalanche Canada, and we do some snazzy weather maps. So those are very much what I was showing earlier in terms of lines of equal pressure. You can kind of see the low and the indicated with the L there, and the high indicated with the H. So you get those maps, and you get a nice jazzy weather description of what our thinking and our thought process is in terms of weather incoming and that sort of thing for BC. In the wintertime, kind of November through March and April, it's certainly geared towards Avalanche Canada. and making sure that they get the most out of it so that they can do some very good avalanche forecasts to keep people safe there. On the off season, it turns into more of just kind of, I would say, a weather description. And our partners kind of include Emergency Management BC, BC Hydro, River Forecast Center, the BC Parks. So it becomes a little bit more less specific in terms of, say, mentioning snow and elevations, and it's more of just a general weather discussion. But I would encourage you, if you're interested, to check it out. It's a good resource. So maybe I'll just say in closing, hopefully I've brought more of a kind of a human side to the forecasting. It's been a strange, I would say, 2 years. This photo was taken, I can assure you, well before COVID, clearly. But you know, there's a nice team of meteorologists who are very, very passionate about the weather and about forecasting, making sure that you guys are safe out there. And so certainly, you know, reach out to us if you ever have any questions and that sort of thing. This was our Sun Run team, which I was the captain of. So Vancouver Sun Run, some of you may be familiar with. So we were able to get everybody together outside and actually do that and participate in that, which was kind of fun. So we're slowly getting back. That was pre-COVID photo. So with that, I'll say thank you very much, merci beaucoup, and you know, I'm happy to take any questions that you guys have, or if there's anything that wasn't, you know, any clarity on anything, I'm happy to talk about that. Any stories you want to share? Again, it's kind of an open conversation at this point. If you guys just want to tell me some good stories, I'm happy to hear those. And again, it's a symbiotic kind of relationship. You know, hopefully I've been able to empower you and share some good stuff with you guys. And you know, it's always good to take something back to the forecast office to make the forecasts better as well. So
if anybody has a question, please unmute yourself, because I've muted everybody, and go ahead and ask. And I'm actually going to start off with one, Ross. Again, I'm not much of a cell phone user, so I'm probably the last one to understand all of it. But does Environment Canada have an app for the cell phones?
We do. It's a good question. The caveat is that it's for public weather forecasts only. So there's no marine forecasts on there, unfortunately. Okay. And so the app is called WeatherCan, and it's a good app, and it's got our 7-day forecasts out there, and it's actually quite slick in terms of weather notifications. If there's a watch or a warning or anything that's been issued for your particular area, it's geolocated on your cell phone. Wherever you go, it can change with your location. So it's all kind of the technology of the day, but it's limited to public forecasting. So what I've been told is that we're working on a marine one. So hopefully stay tuned with that, but hopefully we'll see that you know, relatively soon.
Anybody else?
There were some in the chat.
Sorry?
There were some in the chat just now.
Okay, somebody in chat, any questions?
Oh yes. Okay, so I see one, the link to the high resolution computer model. So let me, I am going to send you something, Fred, at the end of this with summarizing it all. But if you give me a moment, I will try and find it. If I can't find it right now, I promise I will get it to you quite soon afterwards. Okay. But yes, I will get that to you. Please be patient.
Whatever you send me, Ross, we'll distribute it to our members.
Sure,
and maybe post it either on our Facebook page or on our website, so everybody can have a look at it.
Absolutely.
Okay.
Fred, Don here. I'm just wondering what you think of the various apps that are available, like Windy and Predict Wind, which can have pretty low resolution or low like 1.5 mile or 2 mile predictions. And I'm wondering what you think of those as apps and how reliable we should be, how much we can rely upon them.
Yeah, that's a good question. Yeah, so I would say, yeah, I mean, it's the 21st century that we kind of live in, where, you know, I think back to when I, as a, you know, a weather nerd, you know, when I'm in high school or university, and, you know, the internet was so young in those days that, you know, getting weather information, it just wasn't available. And now it's just changed, and there's so much information available, and it's all at your fingertips. Windy.com is actually really good. And I can say that actually as a marine forecaster, as well as other forecasters, we have that up usually on our desk. It's usually not the first thing we look at, but it's a slick software, and it looks really good too. It's visually very, it's very eye-catching. The trick is that the resolution isn't as fine as some of our high resolution models. So it might be a little bit more coarse. But one of the nice things about windy.com is you actually have the ability to change models too. So you could look at, say, an American or UK Met or a European model, or the Canadian. German and Japanese, I think, are on there as well. It's actually a very, very powerful tool, kind of all assembled in one, and it's great. But the caveat that I would throw is that just use it, but use it, say, with our forecasts and that sort of thing. So, you know, if it's one of those things that if, you know, if our forecast is showing moderate winds or something like that, and the model is maybe showing nothing at all, you know, maybe need to do a little bit more of a deep dive. Or conversely, you know, it's perhaps showing something strong. And anyways, just, I would say use it, but use it with our forecasts there.
And predict wind?
Predict wind, I don't know, actually. That's a new one. And actually that's the nice thing when I when I do these talks, it's always nice to get the new one, say ones that I had not heard of. And I'm actually just looking at it right now. But it's so you've used it then? Is it so kind of same kind of idea that it shows visually where the winds are?
Yeah, it does, and it gives you again fairly decent resolution. You can get it at least. Most of us are just using the free version of it, but for like $30 or something, you get a more detailed version.
Yeah, okay. Yeah, I see. Okay, that's great. Okay.
It's my understanding, Ross, that on the Predict Wind, that if you pay for the app, that you can actually get a percentage of correctness. You can go back over to last week and see who had the highest average of accurate predictions.
Oh, okay. Whose model's verifying the highest? That's good. Okay, I like that. We have something in-house as well, but that's pretty slick that it's available. I guess you have to pay the fee, but that's pretty slick that it's available there.
Yeah. As a bit of an aside, the other night I was watching a short documentary on weather apps on one of the streaming channels. And what they said was that the weather information that comes out of the United States, just like Canada, is free. And all of the weather apps have access to that information, and then they use it to make a profit by selling it to people that want that information for a variety of reasons. But when I think it's NOAA in the States, anyways, when NOAA went to put together their own app for people to use, the lobbying from the for-profit weather folks was so strong that it stopped them from being able to release it.
Wow. Okay. Yeah. That's
money in the wind.
Yeah, indeed. Yeah, I mean, that's just the thing. It's yeah, the weather. I mean, it's a very the endeavor of kind of better forecasting is benefits when the data is free in terms of like data sharing between nations. There's never any benefit of, say, a nation restricting data, you know, weather data over another, because, you know, more data is usually improving the models. But of course, when you put that in the hands of those who maybe want to parse it and or parlay that into a bit of a profit, yeah, we're a nonprofit with the we're in the business of safety and security and that sort of thing for Canadians, but no profit here. So unless you go to rossesweather.com, which I'll encourage you to go to. No, just kidding.
Okay. Are there other questions for Ross?
Somebody wanted to know about the heat dome, Fred.
Sorry.
Somebody wanted to know about the heat dome, if there's going to be another heat dome this summer.
Right. Gail just told me that somebody had asked if there's going to be another heat dome this summer.
Oh yeah, so a good question. Yeah, I hope not. It was pretty devastating, and honestly, it's just that was we've seen various kind of case studies that we've done in house, as well as some of our friends with the NOAA and some of our colleagues at the National Weather Service in Seattle, and that was just an extraordinary event. Are we going to see it again? I would probably say no. But it's one of those things with climate change. I think the likelihood of something like that happening is going to generally increase. But it is one of those things that we may not see it. For myself, it might be a once in a career thing. Some of the heat was on the levels that was really never ever seen around here before. So obviously never say never. With climate change, I would say the likelihood is generally increasing. But for this particular summer, I guess we'll have to wait and see. But on average, we'll probably see heat, but something of that magnitude is unlikely.
So if there are no other questions, I want to thank you, Ross, for a really interesting presentation. The second time, I think I learned a lot more. It's certainly important to us as kayakers to know what we're facing when we go out for a paddle, even on a day like today. So again, thank you. We've got one of our much sought after Siska mugs, which I'll mail to you. I'll get your information offline and throw it in the mail in the next couple of days. So thank you.
Yeah, my pleasure.
Before I throw it back to Lynn, we're starting to put our programs together for next fall and next winter. So if people have ideas or subjects or topics that they think would be of interest to the group, please email them to Gail and I, and we'll see if we can add them to the list of possibilities. So I'm going to throw it back to Lynn. By the way, this is our last meeting of the spring, and hope to see everybody either out on the water or in our first meeting in September. Lynn?
Thanks very much, Fred, and thanks very much to you. This was so useful. We actually had a presentation about 3 or 4 years ago, so many of us got The Wind Came All Ways, and it's I found it a tough read, I have to say, but it's one of those books that you have to go back to over and over again. And Ross, I think your talk has made it so much easier for us, and I'm glad we can go back to your talk again, because just as Fred said, I think we'll all learn the more we listen and keep ourselves safer, and that is very much one of Siska's goals, is to have fun on the water, but to do it safely. So thank you for supporting that, and thanks everyone, and have a wonderful time with your child. I have a 13-month-old grandson, which is even more fun because you can return it at times.
Yes, I have to say I'm looking forward to those years as well.
And everyone else, have a wonderful summer. Have a good time on the water, and check your weather. Any comments from anyone left? But I see where our numbers are going down. But thank you very much, Ross. I really appreciated it.
You betcha. My pleasure.
Good night.
Good night.
Bye-bye.